budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Good morning, dear colleagues and guests. Thank you for joining Innovation Days webinar. Innovation Days events are sequels of seminars and webinars organized by Motors Foundation, dedicated to latest in maritime, port, energy, transport, digitalization, and alternative fuels. I'm Emil Wawrowski, Managing Director of Motors Foundation, and lead you through the sessions of the agenda today and through the webinar. Well, the theme of today's webinar is alternative energy, the path towards green transportation. We will focus on the topics of alternative energy sources in maritime transportation, mainly including onshore power supply, the liquefied natural gas, which has been on for a while between us, the colleagues which were utilizing this option. In addition, we will take a closer look to the opportunities surrounding the use of the other alternative fuels, the ammonia, hydrogen, and methanol. Soon we will start with a keynote speech by the Baltic Ports Organization and follow up with presentation of our main partner, Port of Gdynia. After that, we will see presentation by our partners Shorelink and Polski Rejestr Statków. In addition, we'll have other presentations which are hot topics in these days. We will mainly hit the topics of onshore power supply and LNG, low emission propulsion systems, port infrastructure for alternative fuels, and also the outlook of the new fuels, the ammonia and hydrogen and other. So I would like to ask you to please, for any questions to the speakers, please use the YouTube section, write the question down, and we'll have help from our colleague Krzysztof, who will send the questions to the speakers. And your questions will be answered in a YouTube live chat after that. So without wasting any more time, I would like to invite our first speaker. On behalf of the Baltic Ports Organization, I would like to introduce Mr. Bogdan Oldakowski to give us a keynote speech on what is the latest of these new upcoming alternative fuels. What is the latest on the LNG, which has been introduced for a while and supported by Baltic Ports Organization among the ports in the Baltic. So Bogdan, the stage is yours. If you're ready, please.
Emil, thank you very much for giving me opportunity to present you some thoughts about next decade. And particularly, I'll be speaking about what the impact of the climate reduction policies are for the shipping sector and for the ports. I'm just starting. Can you see my presentation now?
Yes, we can see your presentation, please.
Okay. This is great. So first of all, I'll talk about so-called new era of actions against climate change, and then I focus a bit on shipping. However, I must say I'm not the really shipping expert. I'm more a port sector. So after that, I go to the port sector and come and end with some conclusions. Just one slide about Baltic Ports Organization. We were established quite a long time ago, in fact 30 years ago, and we are recently about 50 members from all countries around the Baltic Sea. And I have a pleasure to lead the office of the Baltic Ports Organization for more than 10 years now. But let's go to the main subject. The main subject is, of course, the policies that are focusing on reduction of greenhouse gases to atmosphere. And first, let me start with European Green Deal. The European Green Deal is a policy that was introduced, I think, about 2 years ago, together with a new commission that was enforced at the same time. So it focused on the reduction of greenhouse gases, and it says that Europeans should become climate neutral in year 2050. And quite recently, in December last year, the Commission said that we should reduce in Europe the emissions by 55% in year 2030. So it is a very ambitious goals. Moreover, they said that European economy should be based shouldn't be based on fossil fuels. Well, this is, I have to say, very, very ambitious goals, and the question would be how to meet these goals. But let's go on. You can see now the other piece of European policy is EU mobility strategy, and then in this respect they said that by year 2030 the inland waterways and short sea shipping should be increased by 25% and even more by year 2050. And then they also said that zero emission ocean going vessels should be also ready for market quite recent in a short distance from now in year 2030. Well, again, very, very ambitious goals. Then we do have this Paris Agreement that was signed in year 2015, and it was more based on the temperature. So they said that all the countries who signed the agreement, and within these countries there was Russia, but also China, all these countries should focus to limit the increase of average temperature not more than 2% comparing to the pre-industrial time. And after that, in year 2018, IMO said that the total emissions from shipping should be decreased by 50% in year 2050 comparing to year 2008. So again, another very ambitious goals. And then quite recently, last week, we had a so-called Biden Climate Summit. And if you follow this summit, you could see that there was a series of declarations from a number of world leaders. And among them, Biden declared that US will reduce the emissions by 50% by year 2030. Of course, it is completely change of the policy from US comparing to the previous president. But at the same summit, you could hear another declarations from Canada, from China, even from Japan. Also, Vladimir Putin said something, but maybe it's not that important at the moment. So let me go on. So all these strategies are very, very ambitious. And of course, shipping and port sector are part of the world. So shipping companies, ports, sooner or later must find some role in this development. And I just want to show you a few examples from the shipping sector of initiatives, not maybe only by single shipping companies, but by the sector as such. And quite recently, there was the establishment of so-called Center for Zero Carbon Shipping from Maersk Mc-Kinney Møller, and it is based in Copenhagen. And if you look at the partners, so you could find that there are really big names, big brands in shipping, but also the suppliers for shipping. So simply, their role is to assist or to give the directions for shipping, how they should meet these goals. Of course, one of the main challenges is the technology. What kind of the propulsion, what kind of fuel shipping industry must use in the future. And then another initiative in Asia, again, big names, Samsung among them, but also Lloyd's Registers. They focused to build ammonium fuel tanker, but it's just the first project, and they declared that they will work further to develop technology for climate neutral shipping. And then one of the examples from Maersk quite recently declared that they will design and put into the operation a first zero emission ship. And they said it will be a box ship, the container ship, not too big, 2000 TEU. And she will be operating in intra-regional market, maybe in Europe. And it will be fueled by methanol and also as a dual fuel system by so-called very low sulfur fuel, sulfur fuel. Yes, and then what next? Let me now go to the port sector. And if you see this graph, this is the power generation in Europe. You could see that all these reduction policies, climate reduction policies, will change the energy mix in Europe. So you could see that the coal and the oil, the gas, will be disappearing almost from energy production in Europe. Instead, there will be a renewable energy, but also a quite substantial part will be produced from nuclear sources. So what that means, this is a clear picture that we could expect that coal, oil, and gas probably will be maybe not disappearing, but the volumes in ports will be much lower. So those ports who are profiling on handling natural resources like oil, coal, gas, they have to simply look for another business profile in next decades. And this is more or less the same. Is the demand for coal and oil in different regions in the world. You could see Europe. Europe is a dark blue. So again, a similar picture. So there will be less and less demand for these commodities in Europe, but also in other regions of the world as well. So ports, as they are now traditionally, they are the hubs for natural fuels. They will become more hubs for renewable sources like offshore wind farms, but also they might become a place where so-called green hydrogen would be produced. This is just the example from the Baltic. You could see the picture of a Ronna port, and they just built offshore base for offshore wind farms projects for the Baltic, and I have to say they are quite successful. You know, there are so many projects in offshore industry coming to the Baltic. So simply they did what they expected in a business, and now they are profiting from this development. I know that, of course, there are also such plans in Poland to build offshore wind farms for planned offshore wind farms in the Baltic in Polish waters. Well, you could ask, what are the other consequences of this gas emission reduction policies? You could see that, for example, some ports now declaring the goals of the reduction of the emissions, and you can see here just one of them. Port of Helsinki said that it will be climate neutral by year 2035, and just also quite recently Port of Tallinn said that they will use only green electricity. So this is just the examples of two ports from the Baltic Sea. And of course, another quite important development is the onshore power supply, and the European Green Deal said clearly that ships that are berthing in European ports must use onshore power supply. That means that quite many European ports must invest in this technology. Probably not in every key, but there will be a massive investments in this particular facilities in coming years, decade, or maybe 2 decades. This is just one of the examples of the onshore power supply in Port of Istad and the Polish ship operated by Unity Line. And then one of the main question, of course, for the port is, what is the next fuel for ships? And in fact, I had a very interesting talks just recently from this Maersk center from Copenhagen, and they were asking me how Baltic ports were preparing for bunkering of LNG. Well, I said that it took about 10 years to get to the place where we are now, that you can bunker LNG almost in every port in the Baltic. So the question would be, and this is the question from the ports addressed to shipping industry, what is the next fuel for ships? Because ports must do their own task. They have to be prepared for that development. And of course, at the moment, there is no clear answer. But I think the next decades will be very interesting for that development. And as I said, it took about 10 years for the ports to get prepared for bunkering of LNG around the Baltic Sea. So coming to the end, very short conclusions. What that means, what all this development, all these policies, and as you can see, supported by world leaders, what that means for maritime transport. I would say for the shipping is a huge, is a massive challenge. It's mainly the technology. So what kind of fuel, how you will power ships in the future. And this, of course, will cost money. Probably it will be quite an expensive development. But for ports, I would say maybe the challenge is not as big as for shipping industry. I would say it's rather a change. So ports must adopt to new trends. But if we look at the history, the ports did that lesson, and I gave you just an example of LNG as a new fuel. But then you can expect a bit more challenges, not just one fuel. It will be a harder task, but it will be, I think, for the port sector much easier than for the shipping sectors. So with this, I would like to end my short presentation. And if you are interested in our work, in our activities, please follow our social media and our newsletters. Emil, thank you very much.
Thank you, Mr. Oldakowski, for an excellent overview of the alternative fuel sector, how they are applied in the Baltic ports, and as well, what is the latest from the European Union programs and support, and mostly awaited Green Deal. Any questions will be posted to you at the live chat section in YouTube. And now, thank you once again. And I would like to...
Thank you very much.
Thank you. I would like to continue with the next presentation. I would like to invite Mr. Maciej Krzyżynski from Port of Gdynia Authority to give us a presentation on port infrastructure for powering vessel, onshore power supply, and LNG. What is existing now, how you're managing in this current time. So, Mr. Krzyżynski, representative of our main partner, please give us your presentation. Thank you.
Hello, everyone. Thank you very much for introduction and for the invitation on this meeting. I would like to present you in few words what we did in Port of Gdynia and what we do just now in Port of Gdynia. Just a second. Okay, is it okay? Can you see?
Yes, we can see the presentation.
Okay, we'll talk about the bunkering and the OPS installation in the Port of Gdynia. In few words about our port, maybe somebody don't know our port. We are a very universal modern port with a great geographic location. We specialized in the handling, specialized just now in especially in the short sea shipping services. But of course, our main goal is to build a completely new terminal on the Gdańska Bay, the outer port, and it will be a next deep water container terminal on the Polish coast. Basic navigational and technical data of our port. Entrance to the main entrance to the port is 150 meters with the depth of 13 meters. Total area is nearly 1,000 hectares. 274 is managed by Port of Gdynia Authority. Total length of quays is 11.7 kilometers, and max draw just now is 13 meters. But of course, in the next 2-3 years, we will have 15.5 meters. So we will be the deep water terminal, and we will have much better navigational conditions in our port. Generally, every year we have much more cargo handling in our port. Last year we handled over 24.5 million tons. We have much more vessels in our port every year, and every year we have much more vessels with the LNG powered. So that is why we try to introduce completely new solutions in our port. One of them is LNG, but the newest is a new public ferry terminal with the onshore power supply. And this is a small picture what I want to show you. The main terminal is built on the Polskie Quay, very close to the main entrance to the port. This is, of course, generally the view for the terminal, but the main components of this terminal is, of course, the building of the terminal here, the storeyards, as you can see here, of course, the gallery, but two-level, very smart two-level ramp. And of course, the one of the most important in our port, and the first one in the Polish ports, onshore power supply system, which will be located very close to the ramp, more or less in this place. This is one of the components of the new system. Just now it is existing. Of course, we try to finish all the works on the terminal at the end of June this year. But of course, we will have, as you can see, all the components, all the elements of the onshore power supply system. This is the first one. It's some kind of track, because our system is connected with the 2 points where the track will be connected to the energy. And this is some pictures which shown us that we have some connectors to the ship. And the second point is located here. It's a container with the main system of the onshore power supply. It's maybe one question: why we don't have a crane? We have a truck, because this terminal is prepared for the many kinds of different vessels. I hope that we will host and serve different ferry here. That is why we have to be prepared for the different kind of and different place when we have to connect to the vessel and of course to the shore. That is why we decided about the truck, not about the crane, as it usually is used in the port, in the west port of the Europe. The main parameters of this solution's frequency can be changed from 15 to 16 megahertz. The power of the connections, maximum of course power of the connection is 3 megawatts. And voltage is 11 kilovolts. Sorry. This is the main parameters. In few words about LNG bunkering, we are the first port which regularly bunkering the vessels in our port. The first bunkering was more or less 2 years ago, and we still do that regularly. The first vessel which was bunkered, it was Ireland. It's not a big vessel. More or less, it was a vessel about 100 meters length. But it was the first bunkering in Polish ports. Before that, we did a big work with the procedures, and it was the today I can say that it was the worst work to do. This is a short film how we do that. It is without the voice, so it's on a picture. It's on 30 seconds. Yes, it was one of the first vessels. We do that from the tracks, as you can see today. I hope that today this is much more flexible than building of the some special installation on the quay, because we can do that on the different quays. For us, it's very important. We do that today on the generally on the three quays. First of them is the Rotterdamski quay here. The second one is Polskie quay here, and the third one is Francuski quay. And this is the place. These are the places where we bunkering the vessels in our port generally. The Francuski quay is, I can say, most flexible, most universal for the different kind of vessels. So I can say that this is the best one in our port. As I told you, we do the bunkering from the trucks, but of course, I hope that in the near future, we will do that from the bunkering vessel. We are waiting as a port of Gdynia authority for the maybe Polish bunkering vessel, but of course, it is possible to use the vessels from the other ship owners, not only from Poland. We try to talk with the partners which are interested in cooperation with us. But just now we are waiting for the future to see what the future bring to us. Of course, the bunkering vessels is not only the operation of bunkering. Very important in our port is to prepare to some kind of the crisis situations, and that is why we try to train our firefighters, the firefighters of the Państwowa Straż Pożarna, and generally some of services existing in our ports. It's very important because this is the very important thing what we can use in our procedures. And as I told you, the main problem before the first bunkering was how to prepare the documentation and how we should to have some permission for the bunkering in the Polish ports, because unfortunately we have no we have not the law allowed us for bunkering in Poland. That is why every bunkering operation should be realized and operated on and based on the separate permissions. How to cooperate with Port of Gdynia? Ship owners who want to buy LNG and of course LNG supplier who wants to deliver LNG to our port should send request for the email address lng@port.gdynia.pl, and the next stage is to sign the contract with the Port of Gdynia authority and to have the permission from the Maritime Office in Gdynia. Of course, we as a Port of Gdynia are very interested in LNG, so we try to help every ship owners and every LNG supplier to have some permissions from the Maritime Office in Gdynia. And the next stage is we show the place and the conditions of the LNG bunkering in the Port of Gdynia, and the next stage is of course the bunkering operation. It's not very difficult for the new supplier or for the new ship owners. Just now we cooperate with two suppliers in our port, and we have in our port more or less 3 ship owners which have the vessels with the LNG powered vessels. It's a unifeeder, it's container ships, and of course it's the operator of the island, sealand, and etc. That is all from my side. If you have any questions, please contact me. Thank you very much.
Thank you, Mr. Krzyżynski, for the great presentation. Give us an overview on the latest with the LNG infrastructure, and as well with OPS, what has been achieved in the Port of Gdynia. We are pleased to see that you're following that green port model, and you serve as an example to other ports. And as a part of Baltic Ports Organization as well, you're sharing all your achievements to the other ports as well. Thank you for your support in the Port of Gdynia Authority support. If there are any questions, we will forward them to you on the YouTube live chat session. So please remain for a bit longer to answer them. Well, we are slightly ahead of schedule, but this, I guess, is a positive news for Mr. Klaus Koppelmann from Shoreling. And we will be glad to welcome our partner Shoreling to give us an overview on the onshore power supply for ships as an onshore solution for energy source, onshore solution for the ships which are on shore in the port. So Klaus, if you're ready, please give us the presentation and thank you.
Good morning. Warm welcome from Tallinn, Estonia. And thank you very much for inviting me to participate in the event. Happy to be here. My name is Klaus Koppelmann, and I am representing the company called Shorelink. And as mentioned, I am going to share a presentation about supplying power to ships from onshore energy sources. So briefly about what I'm going to tell. So first of all, what it means to have the connection point between the land and the ship, what type of different applications are needed. Then also some feasibility study analysis to show what do the financials say about the shore power. Then also the practical examples of shore power installation, and finally some points to consider while implementing shore power. So Shorelink in brief. So we are an engineering company which is providing tailored shore power solutions for the ports. So we have our own equipment which we develop, design, and manufacture, and our headquarters is based in Tallinn, in Estonia. And the products and services what we are providing are cable management systems and charging solutions for different type of ships. And we also provide feasibility studies so that the ports can understand what it means to have the shore power infrastructure as such, and what are the financials. And we are also a founding member of European Onshore Power Supply Association, which is gathering the companies who are doing business in shore power sector. First of all, when we're talking about connecting the land and ship, it really has to be understand how the connection can be done. So first of all, it depends on what type of ships will be connected, whether it's like ro-ro and ro-pax ferries, whether they are hybrid or fully electric vessels, or cruise ships or container ships. So the next point is of course the amount of room which is available on the quay. Sometimes there is a very narrow space available in order to make the connection between the ship and the vessel. So and the connection equipment has to be designed exactly for the specific berth, I would say. So and then of course the user friendliness and the flexibility in operation, and of course the project budget. So for example, if you are talking about the manual or automatic connection, it really is like a difference in budget. The second point is the power availability, where to get the energy which will be provided to the ship. Of course, the easiest and most convenient solution is to have the direct grid connection if there is enough power available. But in case no, then the additional battery packs can be installed, or local power generation can be done, for example from hydrogen. We did one feasibility study in Estonia with one ferry line as well. And then basically we have analyzed like what it means to have the shore charging there, and whether the power can be provided by the grid directly or through local power generation from the hydrogen. So basically, it's very like well-known vessel line between the land and island in Estonia. And yes, so the analysis showed that basically, of course, if we watch the investment cost as such, the direct grid connection is much cheaper comparing to local power generation from hydrogen. But rather than that, if we are reviewing the OPEX figures, then we see that already today it is really like beneficial to have the shore charging or shore power as such, whether it's being done with direct grid connection or from hydrogen. So we could like summarize from that as hydrogen is like a new technology, it most possibly have to be subsidized in order to accelerate the usage of hydrogen. But on the other hand, it definitely there is a point to have it. So last year we did a project in the port of Tallinn where we installed 6 cable management systems. So basically like 6 connection points for the Ro-Ro and Ro-Pax ferries. There the direct grid connection were used, and the system parameters can be described as 11 kV system, 50 Hertz. So there were no static free frequency conversion used, and then per each connection point, the power which can be transferred is 2.5 to 4 MVAs. And then also the total shore power capacity which were installed during the project was 14.5 megawatts, and the project duration was fairly short, like 1 year. So and today all these connection points they are like finally implemented, and they are in use as well. And then we can also see that in addition to the implementation and financial impacts, the environmental benefits are also quite considerable. And then for cruise, we also we are also currently like doing the project in Norway for the cruise industry. And the conception for this project is the same. So the direct grid connection is being used. So but in this case also the frequency is changed. So I'm provided as 60 Hertz to the vessels, and in this case the mobile connection points are used because the cruise ships which are visiting the quays are every time different, so the connection points are in different places. So it's very like easy and convenient to use such kind of equipment. And what are the points to consider while to implement the shore power? First of all, of course, following IEC 80005 standard, which is a shore power standard. This is mandatory both for the ship side and for the land side, I would say, because the important point is that both sides are capable to connect with each other, and the installations have been done based on the same principles. The next important point is finding a suitable spot on the quay. Whether it's like a stationary equipment to be installed or mobile equipment. And third important point is to have enough grid power or power as such. So for the power availability point of view, to have enough power to provide the energy to the ship. Also the short circuit current, the grid has to be able to resist to that and to switch on and off the big and powerful transformer units. And in case the grid is not strong enough at the port, then additional battery packs or local power generation unit can be used in order to generate the power. And we as ShoreLink, we do have the capability to provide the feasibility studies to investigate the possibilities to have the shore power in a specific port. And yeah, so by the end, yes, bring it back the slide which I showed in the beginning to show you again the different like products and services that we have. So we have by now developed the connection points, the cable management system, for very different type of applications. And whether it's like a Ro-Ro and Ro-Pax, cruise ships, electric vessels, or container terminals. And this is basically it. Thank you.
Thank you, Klaus, for the presentation. We are well ahead of schedule. You were quite good to give us precise information. I would like to use the chance that we have some time. Well, the main question, what is surrounding the OPS onshore power supply installation, is, for example, what are the issues with the onshore power supply? We have some voices raised. There could be differences in a high voltage, low voltage. The differences in the connection systems. Different ships have a different opportunities and options to connect than what is presented at the port infrastructure. Will you be able to give us a bit more information on that, how you're trying to overcome this, that issue with the standardization, and what are the other main challenges what you're experiencing right now? Hope you are hearing us, Klaus.
Yes, sorry, can you please repeat the question?
Yeah.
There was some technical
Yeah,
issues.
sure. In short, we are trying to avoid the main issues with the onshore power supply. We've been receiving some suggestions and comments from fellow ports in the Baltic and other ports. There are still main issues with the standardization of the connectors, of the low and high voltage supply. So are you trying to overcome this solution? Are you concentrating on particular power supply and standardized connections which are to be provided to the ship owners?
Mm-hmm. Yes, I mean, while we are designing our equipment, then yes, so we are trying to pay attention to the standardization as well. So that basically, I mean, the same type of equipment can be also used for other ports. Now, the good thing is that the standard, the IEC 80005, which we are following, is already like giving the principles what has to be taken into account from the connectors, for example, which is connected with a ship. So that's the good thing. I think that one of the main thing is the suitable spot at the quayside, and also whether to use the stationary equipment or mobile equipment, because as you said, you know, different type of vessels are visiting the same berth. So how to be able to provide the equipment which is suitable for every type of ships. Now, this is indeed the main challenge, but I think that by the time the standardization could be take place as well.
Okay, thank you for the answer of this question. That definitely will be of assistance to us. I've got information. There's a question on the YouTube live chat. Will you be able to answer it now, as we have a few more minutes? It's a question from Madly Kopti. You mainly introduce the shore side, Klaus, but based on your experience, what are the main shortcomings from the ship's side?
For the ship side, I mean, we don't have, of course, that long experiences for the ship side, as we are mainly focusing on the shore side. But no, for example, if we are taking the hybrid or electric vessels, then the question is, where the charging equipment will be installed and whether the charging will take place in AC current or DC current. And also, of course, one thing is, designing the vessel from scratch and doing it fully electric, but also the other main subject is to make the conversion on the existing ferries and making them electric. And then the main challenge is to find enough free space where to install the battery packs, where to install the charging equipment. And yeah, again, it depends on how the charging is taking place, whether it's AC or DC, and also the number of equipment depends on that.
Yeah, I understand. So basically, it's critical for you as a supplier of this infrastructure, OPS, to work closely with the ship owners, basically to synchronize these installations to be sound and safe and not to get wasted somewhere in between this standardization. So close work with the ship owners when the ships are retrofitted in order to avoid such complications. Well, that says it quite a lot now. Klaus, thank you once again for your presentation and the support from Sholik, our partner. I would like to move in that case now to our next presentation, which actually is going to give us a bit more information on that design of the ships, exactly the issue what we started just now when we got a retrofitting. That applies to our new ships as well. We've got a need for standardization. And I would like to invite Mr. Krzysztof Czerski from CTech Engineering to give us a presentation on low emission propulsion system and a few examples on the ships, what CTech Engineering is dealing with right now. So Krzysztof, if you are ready, please, stage is yours.
Yes, good morning. Thank you very much. I hope that you can hear me. Then I will try to share my presentation. All right. Could you confirm if you can see my presentation? I will
yes, we can see your presentation, yeah.
Okay, perfect. So, thank you very much. Good morning once more. Thank you very much, Motus Foundation. Thank you very much, your partners, Port Gdynia, Polish Register of Shipping and Shoring, for your kind invitation for CTech Engineering. I would like to present you a little bit what we are doing right now with our new, let's say, developed ships. So it's a pity that again we are meeting with through the screens, not in the real life. To be honest, I'm usually prefer the face-to-face meeting instead of online. But however, I hope that soon the pandemic will be over, and then next session we will have in the nice place when we will have the possibilities to talk face-to-face. So my name is Krzysztof Czerski, and I have a privilege to work with CTech Engineering. CTech Engineering is a ship design company located in Gdańsk, but with small subsidiary offices in Szczecin, close to the German border, and also in Rumia, which is 20 kilometers north from Gdynia. In Rumia, there is energy and LNG and energy department, which I'm leading. So best regards from the sunny Rumia. Now, right now, it's a beautiful sun shining outside the window. So the first slide, this is, let's say, the content of my presentation. And first slide, I would like to start with the short information about the CTEC. We are engineering company established in 2003 as a part of the French group PDU. But however, from 2018, we are fully independent because we had the agreement with PDU that our management of CTEC buy out the shares. So we are totally independent right now company, but however, still very close cooperating with PDU shipyard or PDU shipyard group, because there are a couple of the shipyards around the world. And as a CTEC, we are not only the ship design company, we have also in our, let's say, portfolio, some services for the brokering. So we together with the PDU, we participated in the purchasing or the building of about 30 partly outfitted hulls in Poland, mainly for the French market, but also for the others. So we are doing the ship design, we are doing the retrofit designs, especially the scrubbers and the ballast water treatment systems. And also we are focusing a lot on the LNG bunkering solutions. So I'm really very happy what I heard from Mr. Krzysiński from Port Gdynia authorities. So we really also believe that sooner or later we will have the LNG bunkering vessels here in Polish harbors. So I believe that this vessel will be designed by the Polish design office, maybe by us, and also will be built somewhere in our shipyards. So we also, CTEC is also a representative of the Dassault system software called 3D Experience. So it's not only engineering companies, it's quite very wide scope. So back into the topic of my presentation, I would like to present you 3 different solutions for the low emission propulsion system based on our latest designs. First is the conventional fuel, because with the low emission propulsion system, it doesn't mean that we should concentrate only for the low emission or alternative fuels. We can also propose the low emission propulsion system for the conventional fuel vessel, but only what is the important, this is the very clever optimization of the existing propulsion system, means main engine, which is installed on board. Second proposal, which I would like to present you, is our LNG fueled ferry, which will be able to convert to the future to the other alternative fuels. But however, this ferry is not only running on the LNG, but also on the solar power, and also it is equipped with the connection to the shorelink. So, but however, I will explain later on. And the last, the future, the zero emission future. This is the crew transfer vessel for the wind farm services, and we developed this vessel as a run on the hydrogen. I would like to concentrate on the 3 fuels here: the conventional, let's say low sulfur MDO or marine gas oil, LNG, and also hydrogen. I don't want to touch to the other fuels, because I suppose that the other alternative fuels like methanol and ammonia, they are quite good for the deep sea vessels. But also I don't want to grab some part of the presentation to my great colleague Piotr Kabaciński, who will have the presentation in the end of today's session. Yes, let's back to the, let's say, to our time when we were very young and we were in the study in university, and the professors teach us how to design the propulsion system. Of course, in the conventional way, we had the power curve for the vessel, and we have the service speed, which is given by the owner. And then from the service speed, we will choose the engine. Usually we keep this 15% sea margin for the rough sea, for the current, for the growing of the underwater part. And also we kept some safety margin, let's say, for the engine, because through the years the power is decreasing of the engine, and then we kept this 50% MCR. And also the producers of the engines optimize the engine to have the lowest specific oil consumption just for this contractual point, because this point we called contractual. And this curve is rising when the power is increasing, and also is rising when the power is decreasing, especially for the very low load scenario. For the 50% load, this fuel consumption is really quite very high. Again, this engine was optimized, the engines were optimized for this contractual point. And we call the system conventional. And we have now conventional system SC, but what happened if, due to some different circumstances, the vessel should sail a little bit lower than assumed speed for the in the contract? So what means that we have also the power needed the lower for this lower speed. That means that the consumption curve, which we have here, is giving us the much bigger value of the specific fuel consumptions. Of course, the vessel is generating less, the engine is generating less power, but the consumption sometime is even higher in this lower consumption. What to do? The best way will be to operate this engine in this point. But what to do with the surplus of energy? So this solution is called hybrid. So we can store this surplus of the energy in the battery. And in case of so much energy, the power management system is deciding to store the energy in the batteries. So we call this system hybrid. And this hybrid system is mainly helping us to shaving the peaks of the load of the engine. So thanks to this, we are receiving the more or less average main engine power, which is flat, and all those peaks are transferred when we are loading batteries, when we have so much power, or we are using the power from the battery if we have to add some power due to, I don't know, heavy wind or a rough sea or something like that. And this is this example, the conventional fuel system on the multi-purpose vessel designed by the CTEC. This is the more or less multi-purpose vessel, with the accommodation and the engine forward, because it is creating the big space for the industrial cargo, the box-shaped cargo holds, and also the possibilities to install the long cargo on the deck. On the picture on the beginning of the presentation, there was a visualization of this vessel with the windmill propeller blades, which we suppose that the vessel will be very good for this, let's say, distribution of the wind blades from the main harbor or the producers to the local plants where we will have the installation of the wind farms. The vessel is 100 meters long, and the installed power is 3060 kW plus 400 kW hour installation in the batteries. This is quite small amount. This is something like a 10%, but it is giving us possibilities mainly to do this peak shaving. So when we have the batteries, this vessel is rather not, let's say, designed for the operation in the batteries only. The batteries will be used only for the peak shaving. The power distribution system is more or less looks like here. We have the DC grid here, and we have the generators, diesel generators, which are producing DC energy, direct current energy, and then from this bus bar, we are transmitting the power to the propulsion engines, also DC, and also a surplus of the engines we can transfer to the battery packs, which we have here. And in opposite, when the power of the engines is not enough, we can use the power from the batteries and to transfer to the bus bar and to transfer to the electric motors. We have also connected to this DC grid. We have also boat thruster, which is connected. Then we have the frequency converter, transformer, and then we have the classic conventional distribution switchboard for 440 volts or 400 or 230 volts also. We have the emergency switchboard, and we have all the feeders, and of course we have the shore link. We have the shore link, but however this vessel is quite low consumption. The vessel has the quite small demand for the power, is something like a 350 kW. So I suppose that short connection can be here to the emergency switchboard or to the main, but however AC switchboard. And on the vessel, this system looks like that. We have the engines here, the diesel generators. We have the 3 engines. In this case, we are based on the Wärtsilä 6L20 engines. Then we have the switchboards, the DC and also AC. And we have the batteries, propulsion motors, and the propellers. Of course, here we should have the details like a thrust bearing, etc. But this is only for the presentation purposes, because otherwise the picture will be blocked by the small details, and it will be impossible to see those main components. And the second, let's say, proposal of the low emission propulsion system. This is the LNG fueled double-ended ferry, which we are designed for the new harbor in Poland, means the Elbląg harbor, because I suppose that sooner or later this channel through the Vistula Spit will be ready, and then the Elbląg will be open for the seagoing vessels. And we, let's say, take liberty to propose the LNG dual fuel, let's say the double-ended ferry, running on the LNG, but also on the batteries, which can serve from the Elbląg to the city, to the 3 city harbors, means Gdynia, Gdańsk, and also to the Hel Peninsula. We suppose that Elbląg will be a good place because the Elbląg is the shortest way on the express highway from the Warsaw. And it will be a really great place to board the passengers, and in the summer season to transport those passengers from Elbląg to Hel. Because the distance on the seagoing on the sea road takes something like with the speed of the 24 knots, it takes something like a 2.5 hour, including some decreasing of the speed on the Vistula Lagoon. It will be more or less the same as we will go around the 3 city, Władysławowo, and all harbors up to the Hel. So the 3 hours the driver can rest on board, and they can spend the time with the kids, playing on the kids play here, and also he can see the beautiful Baltic Sea. So I suppose it will be good alternative for the let's say road transport. Also, not only in the summer, we are thinking not only about the summer season but also about the winter season, because the vessel can be this ferry can be very good vessel to supply, for example, trucks from or the buses or the vans for the supplying the shops on the peninsula, restaurants on the peninsula, and they can be transferred by this ferry from Elbląg, and they can serve the goods on the peninsula, especially because on this ferry we have something like 20 connections for the fast charging electric cars. So we can have this ferry like a hub for the charging the local trucks, which can serve which can transfer the goods in the peninsula without any emission. So, but however, this is the concept of the ferry. I would like to talk about the propulsion system. And here we have this ferry. We have the 2 separate engine rooms and 2 separate DC grids from the safety reasons. And because we have the 2 separate grids with the 2 separate tanks, we can avoid situation with the dual fuel engines, but of course they are very good, but we don't want to have any liquid fuel on board. We have only LNG, and after regasification, we are transferring this LNG to this aft engine room and also to this forward engine room when we have the gas generators, again with the DC grids. And this DC grid is transferring through this DC grid, we're transferring power to the main propulsion motors and also to the battery packs. And also what I forgot to mention, the vessel has the solar panels, which is something like 300 solar panels on the roof. So we have something like 80 kilowatts which are available to charge the batteries from the solar power with the, let's say, of course, in the daytime. We have also the shore connection. We can have the shore connection to the DC grid, but I suppose that because then we don't want to be, let's say, rely on the one harbor only, so we can rather connect to the shore connection to the AC grid. I'm really happy to hear what Mr. Koppelman presents about this solutions from the shore link. So it is really a good proposal for our vessel. And then we have the feeders mainly in the kind of accommodation area. And here we have this vessel, and this system looks like that. We have the LNG tanks with the regasification system. We have the diesel engines, we have the switchboards, batteries, solar panels on the roof, and we have the propulsion pods, 4 pods, which has the possibilities to turn 360 degrees, so the vessel can have the excellent maneuverability for the crabbing, for the turning, and for the all operation in the tight harbors like Elbląg Harbor is. So when we are designing this vessel, also we are thinking about the future, because the hull probably will be okay after the 20-30 years. But we still don't know what the future brings. I don't know if the Motus Foundation will invite me for the Innovation Days 2031 or 2035. So maybe we will have the more clear view about the future, but however, for time being, this vessel is designed that very easy we can replace the LNG tanks by the liquid hydrogen tanks, and the engines we can replace with the fuel cells. And then we are receiving the vessel, which is totally zero emission vessel running only on the hydrogen. And this preparation for the hydrogen on the ferry is giving me the possibilities to also to present you our newest, let's say, hydrogen operated vessel, which is the wind farm crew transfer vessel, which we designed especially for our Polish offshore wind farms, which are in plans. I suppose that sooner or later somebody will start to do not only talk, but also to start to do the real job on this wind farms. And this is the hydrogen vessel which can transfer the servicemen from the harbors to the windmills to do the service, to do the maintenance and everything. The vessel is quite small, but however quite powerful. It is 1,250 kW plus 280 kW on the batteries. The vessel has 4 crew members with the 4 berths and also 12 seats for the passengers. Eventually can be transferred to the 2 crew members with the 2 berths and also 24 seats for the passengers. The vessel is catamaran, and in each catamaran we have this DC grid with the fuel cells. When that hydrogen is transferring from the tank, which is installed on the open deck, which is right here, and the bunkering of the vessel is done by the replacing of this container. Additionally, on this top of the container, we have excellent space for the small solar panels. So even we can have the surplus of from the solar on this vessel as well. So we have the DC grid, again, batteries, propulsion motor. It can be jet or it can be conventional propulsion. Then we have the frequency converter to the DC. We have the transformer to the DC grid. Because on the small boats, usually all equipment is running on the low voltage, 24 volts, or radio navigation equipment, some small pumps, because everything is small on this vessel. And then eventually we can have the frequency converter and the small DC AC grid for the short connection, and also for the small feeders in the accommodation area for the kitchen, or for the charging the mobile phones, computers, etc. So, and again, how it looks on the real vessel, we have the H2 tank. We base for the time being on the compressed hydrogen technology, but however, I'm rather supporting the idea of the liquid hydrogen with the low temperature, -250, because let's say, my background is from the LNG department, so I'm always saying that whatever we can learn on the LNG, we can use this cryogenical knowledge on the hydrogen, on the liquid hydrogen. So I suppose that it can be sooner or later replaced by the liquid hydrogen with the small cold box for the regasification of this liquid hydrogen. But for the time being, we have this compressed hydrogen, and we have the hydrogen lines which are supplying the fuel cells. And then we have the switchboards, batteries, and the propulsors, which can be jets or the fixed or the fixed propellers with the conventional rudders. Yes, and small summary in the comparison, when we can say that the conventional diesel mechanical propulsion is something like a 100% of the emission of the CO2, because I'm taking care about the emission of the CO2, because we have, of course, the emission of the SOx, but however, now due to the new IMO rules, we have 0.5 level globally and 0.1 here in Baltic Sea and the coastline of the US. But then we have NOx, which is, let's say, limited by the tier 3, which is now is quite low, and the all vessels has the SCR, selective cathodic reactor. So let's have the only CO2 emissions. So conventional vessel will have the 100% of the emission. Then for this conventional fuel, but when we will use the low sulfur fuel, forget about the scrubbers, because the scrubbers are not killing the emissions. They are only transferring the emissions from the air to the sea or to some chemicals which we should have export from board. But however, compared with this low sulfur fuel, we have something about 15% of the reduction. But of course, this is everything depends on the operation profile of the vessel. And then we have our Elbląg ferry with this hybrid LNG propulsion system plus solar plus shore power. Then we are assuming that the operation in the harbors in Elbląg, Tricity, or in Hel can be done on the batteries only. The transfer through the Elbląg River on the also Vistula Lagoon and Vistula Channel will be done on the batteries, and we will use only the engines on the open sea. And then we suppose that we can run something like a 50% of the time on the batteries, 50% of the time so on the LNG. So in taking into account that the CO2 emission on the LNG propelled vessel is smaller than compared with the conventional fuel, we can say that we can have some 60% reduction of the emissions. And of course, future, when we can base in our crew transfer vessel on the green hydrogen, then we should have almost zero emission from this vessel. So thank you very much. In case of any questions, of course, I will be happy to answer on using this channel on the YouTube. So once more, thank you very much, and have a great rest of the webinar.
Thank you, Mr. Czerski, for the comprehensive presentation on the CTEC's projects and plans, what you are trying to achieve now. It's very interesting to see that not just the LNG and bio-LNG is on your main topics and on top of your lists, but for me personally, it was very interesting to see the new solutions, the hybrid version between LNG and a solar onshore supply. So very versatile and very good propositions for the ship owners. I hope by this we will try to avoid this constant problem what was in the past, like with a similar introduction when LNG was a new solution. So very encouraging, very good prototypes you have presented. Thank you for your time and for your support. If there are any questions, they will be posted on the YouTube live chat. Well, with that said, I would like to announce that we are finalizing the first session of the today's webinar. We introduce mainly the OPS, LNG, as well the actual solutions for new propulsion systems for new vessels. Well, with that said, I would like to announce that we have a short break and for 15 minutes, and we will reconvene in 10:35 with the second session of today's webinar based on the future alternative fuels, what we are about to see, what is the next step, what is to be coming in the next decade in the long term. So thank you for joining us. Please reconvene at 10:35 to continue with the second session of the event. See you soon.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.
Good morning once again, dear colleagues and friends, and thank you for joining Innovation Days webinar today. We are on schedule to continue with the second session of webinar, which is dedicated to the the next step of alternative fuels, the new fuels, and the outlook in a midterm and in a long term. We will have presentations from Hydrogen Europe and from our partner Polski Rejestr Statków. After that, we'll have a case study from Port of Tallinn dedicated on implementation of LNG and onshore power supply. And we will conclude with Varsila's summary and outlook for the future fuels and what is the best one, what is the one which will solve it all. Will it be such a fuel, or will have a mixture of all these current green fuels? So with that said, I would like to continue further with the next presentation from Mr. Grzegorz Pawelec from Hydrogen Europe to give us information on the organization, some of the supply chains and conditions for the use of hydrogen fuel in the transport sector. Grzegorz, if you can hear us, the stage is yours. Please do your presentation.
Yes, I can hear you. Hello, good morning. Thank you for inviting me. I'll share my screen in a second. I hope you can see it. So indeed, I will talk a little about the hydrogen technologies and the potential application in the maritime sector. I would like to first start with a couple of words about the organization I represent, Hydrogen Europe. We are an industry association representing the hydrogen industry in Europe, but not, let's say, not the whole hydrogen industry, only the clean hydrogen industry part of it. So we focus mostly on renewable hydrogen, low carbon hydrogen, and we see it basically as a potential vector to decarbonize the whole society and European economy. Obviously, the maritime sector is a part of that. But we are not just any hydrogen association. We have a let's say a second part of what we do, which is we are partners together with the European Commission in the Fuel Cell and Hydrogen Joint Undertaking, which is a program to fund R&D activities in the clean hydrogen sector, focusing on energy and transport sector, and maritime is part of that. So far, we have funded more than 1 billion euro worth of projects in the previous 14 years. And this is important also to understand kind of why we have did this analysis that I will present in the next slides. Because this was let's say, the beginning of this analysis was to inform our research and innovation agenda of this particular funding program. So we wanted to find out for ourselves also if hydrogen makes sense in the maritime sector at all, and if it does, which sectors or which applications should we focus on when we discuss the hydrogen application in the sector. So here it was what we covered in the analysis, and because, as I mentioned, this was aimed at informing our own strategic research and innovation agenda, we did not focus on batteries, we did not focus on biofuels. This is not to say that those are not viable options for the maritime sector, but it just was out of scope of our analysis. So what we did look at, so we focused on renewable hydrogen as a starting point, and then we obviously looked at various ways you can use that hydrogen in the shipping sector. And you can obviously use it either in compressed form or liquefied form directly, or you can use hydrogen carriers like liquid organic hydrogen carriers. There are also other like metal hydrates, for example, but we focused on the LOHC. Then, of course, you can synthesize the hydrogen with nitrogen captured from the air, and you can produce green ammonia or synthetic ammonia or e-ammonia, whatever name you want to call it, and then use that ammonia as a fuel for the ship. Or you can synthesize the renewable hydrogen with CO2 to produce synthetic methane, LNG, synthetic methanol, or even synthetic diesel. And that CO2 is from a sustainable source. And then obviously those, let's say, ways of doing it are perfectly fine sustainable solutions. There is nothing wrong with those options. And then at the last part, you have various ways of reconverting that, whatever fuel you choose, back into energy. And then you can obviously burn it in an internal combustion engine, as it's mostly done today. Or you can use a fuel cell as your reconverter. It's either low temperature fuel cell or high temperature fuel cell. The low temperature, if you would like to use it with some of those complex fuels like ammonia or the synthetic fuels, would require obviously some reforming on board of a ship, either an ammonia cracker, for example, which would add, let's say, another dimension to the amount of storage that we need on board of a ship to make that fuel work for you. For the high temperature fuel cells, you don't need that, but those cost a bit more. So we took all of those into account. But what's important, what you can already see on this graph is that if you try to, let's say, find all the possible permutations and combinations of those various options, you see that only for hydrogen, there is a couple of dozens possibilities that you can do produce a sustainable fuel with renewable hydrogen. And then if you also look at, let's say, maybe low carbon hydrogen sources from natural gas with CCS and maybe from biofuels, you see that there are just so many options that at this point, this is becoming a bit of a disadvantage because, I mean, it holds back a lot of investment in the field. The ports are not willing to invest in storage or bunkering infrastructure for fuels that they don't know is going to be the one that is the fuel of choice in the future. The ship owners are not willing to invest in new ships using either one of those options because, I mean, if the ships are expected to last for 20, 30 years, you want to invest in an asset that you are certain that in 10 years' time will be able to find the fuel that it needs. So this kind of multiplication of various options is really something that needs to be tackled very soon, and the sector needs to, let's say, converge on some options. And that was one of the also ideas behind this analysis. The first thing that we looked at, obviously, was the cost of fuel production. And this, what you can see on this graph, the blue part shows you the cost of production of the hydrogen itself, that is basis of each of those fuels. And obviously, it costs the same no matter what fuel you then use. And then on top of that, the gray part shows you the additional costs that are needed to turn that hydrogen into the end state of the fuel. So for compressed hydrogen, it is just compression. For liquefied hydrogen, it's liquefaction, which is a bit more expensive and more energy consuming. But if you go to the synthetic fuels, then you get additional, fuel synthesis. You need to synthesize ammonia in a Haber-Bosch synthesis, for example. For LNG, you have to synthesize, you have to first capture the CO2 and then the pure hydrogen options. And that's one of the key, let's say, observations here. It's not a, let's say, groundbreaking one, that the less operations you need to do, the cheaper the fuel will be. But it is also important one to keep in mind that no matter also what assumptions you take about how much renewable energy will cost in the future, whether costs will continue to fall down or not, this kind of ranking will always be true, because the renewable energy and the renewable hydrogen always cost. So the difference between those fuels and the fossil option will obviously change, but the relative ranking of those various fuels will always remain the same, and always the pure hydrogen options will be cheaper than the synthetic fuels. And another observation is that out of the synthetic fuels, ammonia is always going to be cheaper than the other more complex options, because it does not require a carbon molecule, which is an expensive one to get, to be honest. Especially if you assume some kind of sustainable way of capturing via direct air capture, for example, which is also quite energy intensive. So those are the two basic observations. The less simple, let's say, the fuel, the less its cost will be always, and the ammonia is the cheapest option out of all the synthetic fuels. Of course, there are other dimensions to the whole equation, and the other is the energy density of those various fuels. And here you can see that the ranking of those various options is exact opposite of the cost of producing of those fuels. So now the ones that were the cheapest have the lowest energy density and would require the most space on board of a ship. So compressed hydrogen would require 5 times more space than liquid hydrogen, for example, and liquid hydrogen will require twice as much space or even more than liquid LNG, for example, for the same energy content. And this, of course, has an impact on the, let's say, the business model of the ships, because not only will the ship storage system cost more, but at some point it will negatively also impact the revenue generating capacity of those ships. I mean, if you need to limit the amounts of storage capacity, limit the amount of containers that you can carry because you need more space for fuel, that would of course have an impact on the whole business model. And we obviously also looked at that, not only at costs themselves. We also looked at other things than just the energy density of fuels. We also obviously consider the various equipment that would be needed to crack those fuels on board of a ship. We looked at the space required for the boil of gas, for example. We also looked into what would be the relative difference in terms of space required for a fuel cell versus combustion engine. So this was all taken into account. And this is what we basically saw when you combine those all those aspects into monetary terms. So looking at costs and also the value of lost revenues because of the additional space required for a fuel. The ranking is more or less, I mean, similar to the one that I showed on the energy density. But what's important here is that although the ranking remains the same, so some options are always most expensive than others, no matter what ship type you look at. When you look at ships that can be refueled more often, when you look at ships that can be refueled more often or don't require as much energy on board because the engine, the power requirements are just lower than maybe for some other applications, versus, let's say, deep sea shipping applications, you see that even though the relative ranking of those options is always the same, for those smaller ships, even though the most expensive options become much more manageable, let's say, because I mean, even though it's the most expensive one, the additional cost that you actually need to pay is a lot smaller than if you look at deep sea shipping, where those additional costs become prohibitive and just make those applications impossible to implement. Last part of the equation is obviously the energy conversion, so either an engine or a fuel cell. And I don't want to go into details because I mean, but just want to mention two aspects. So first, when it comes to fuel cells, generally they're a bit more energy efficient than combustion engines. So especially in maybe for lower power ranges where the engine has an efficiency of, let's say, 40% or 45%, and a fuel cell can have an efficiency of around 55%. So that's somewhat of an improvement and kind of lessens the additional space that we need for fuel. Then also for some ships that are powered by diesel electric setups that you produce electricity directly from a fuel cell, you don't need let's say a genset additional, so that also gives you some savings. Although on the other hand, where you need this shaft power and mechanical power, then an engine has an advantage because for a fuel cell you then need an electric motor on top of that. But there is also another nice thing to notice here is that there is a difference in terms of the power to efficiency curve for a combustion engine and a fuel cell. Combustion engine, when you reduce the load of the engine below 80% to 60, 40, 50%, the efficiency drops substantially. And that's not the case for a fuel cell. So fuel cell can operate even at 20% of load, and the efficiency there is even higher than at full load. The optimum is around 40% of partial load, when the efficiency can go up to 60%. And this is also an important consideration when you start to consider the operational profile of a ship, because for some applications the average utilization of the power system is usually well below 100% or 80%, or it's closer to 60. And then when you combine all those aspects together, what you can see is that there is just let's say, a dynamic development there, that when you go from the less energy dense options to the more energy dense options, the cost of the fuel always, let's say, increases along that line. But obviously, as the energy density also increases, the impact on the storage costs decreases along the same line. So there is always this kind of trade-off that works differently for various ship types. And we have done this analysis for over 60 different ship types, and here you can see the results. And the results are that indeed, there is place for hydrogen, as we can see in the maritime sector. And what we did see is that for those short sea applications, where you can refuel often, even for some larger ships like ferries, and you can see this with the recently announced DFDS ferry between Oslo and Copenhagen, which is which is planned to run on compressed hydrogen. That even for large ships, this can work if you can refuel them very often. Then for the deep sea shipping applications, it's always synthetic fuels that prevail and are the most cost optimal option. And out of those synthetic fuels, as I mentioned, it's always ammonia that comes out of top. So for no ship type did we find out that the more, let's say, complex options like liquefied hydrogen, liquefied methane, so liquefied natural gas, synthetic methanol, synthetic diesel would be the optimal option. And then there is a big chunk of the market in between those two extremes, where liquid hydrogen seems to be the kind of the best out of those two worlds and give let's say the best combination of cost versus energy density. But if you look at the actual share of the market, so those various ship types have on the market and how much fuel they use, actually around 90% of the whole fuel consumption today would fall to the ammonia option. So even though that only for the, let's say, the larger ships and the deep sea ship application, because there are just so many of those ships and there's so much fuel, that would cover around 90% of the market. Then around 9% would be liquefied hydrogen, and 1% for those short sea shipping applications would be compressed hydrogen. And then the last thing that we looked at in our analysis was to see how much would that cost, basically, in terms of CO2 abatement. So as you well know, that there is currently ongoing discussion about inclusion of the maritime sector in the ETS system, where the current price of CO2 emissions is around 40 euros per ton of CO2, which is forecasted to grow also maybe to around 50 euros per ton around 2030. Although maybe it will be higher, but I mean, those are the expectations. And as you can see on this graph, this will be nowhere near enough to make the ship owners go for those zero emission options, because the break-even point for a fuel switch, it starts at 100 euros per ton, and for some ships it is as high as 250 euros per ton of CO2. So as you can see, I mean, this is not to say that the ETS is a wrong option or anything of that sort, but clearly it will not be enough. So ETS alone will not make any change in terms of ship owners' behavior, or at least not a substantial one. And yeah, basically that would be it. I mean, it might look scary when you look at the cost, the additional cost. But what we also did was look at how much would the actual cost of cargo, let's say, transportation increase versus using the fuel options. And when we look at, for example, that a single cell phone transported in container ships between China and Europe, I mean, the price of that would grow by a couple of dozens of cents per one mobile phone. So while the cost of for the ship owner are quite high, it would certainly not also ruin the economy in any way, provided there is a level playing field, and the European ship owners are subject to the same, let's say, strict regulations that the competitors are as well. So yeah, that would be it from my side. Thank you very much for attention. If there are any questions, I'm happy to answer them.
Well, thank you, Mr. Pawelec, for your presentation, for a very comprehensive one with a good introduction of hydrogen, and we learned quite a lot about Hydrogen Europe as well. As we are quite good on time, I've got a short question. Will hydrogen be the next fuel? Will be the fuel of the future?
Yeah, well, I certainly hope so. But what we see is that it might play a big role in Europe for the intra-EU operations. But when you look at global shipping, then it becomes clear that it needs to be let's say a global consensus somewhere, because I mean you cannot think that the fuels will use whatever synthetic fuel at the end will prevail and tank it just in Europe, and I mean China will go for some other option and USA will go for some other option. It needs to be a bit more coherent. And then, if it does indeed go this way, we see that for deep sea shipping application, indeed, hydrogen might have a difficult time, because it's just this energy density of it is I mean half that of those synthetic fuels. So the impact on the storage capacity is quite significant. But to be honest, I mean, we don't really mind that. I mean, all those synthetic options in the end would require renewable hydrogen anyway. For their production. So from that point of view, we are perfectly happy to support whatever fuel is chosen by the industry. But I mean, what we just say is that the industry should hurry up and make the choice as soon as possible, because even though the targets are set for 2050, given the fact that the ships are in operation for 20-30 years, actually the change needs to start soon.
I see. Thank you for commenting for your presentation. Well, with that said, I would like to continue further on our presentation with our partner Polski Rejestr Statków, and I would like to invite Mr. Marek Narewski to give a presentation on selected aspects for safe use of alternative fuels on small vessels. Mr. Narewski, if you can hear us, please do your presentation. Thank you. Yes, we can see the presentation now.
Unmute. Yeah. Do you hear me? I think. Yeah.
Yeah, we can see the presentation. Just if you are able to make it on full screen, that would be great. Yeah, thanks. We got it now.
Yeah. So once again, good morning. Thank you, organizers, to have a chance to create a chance for us to tell a little bit about alternative fuels, about hydrogen, about small vessels, and some safety aspects. Polish Register of Shipping, I think if Polish customers are quite well familiarized with PRS. I don't know whether we have some people from outside Poland, but anyway, data about the PRS could be found on the webpage. We are classification society, Polish classification society, working in a global market together with 12 other classification societies. We are a member of IAX. We are having a set of authorization from flag states. It's about 40 right now. We are recognized by European Union for inland waterway transport certification classification, and of course, because trends are as we know are, so we are working also on introduction of regulations on safety issues related to alternative fuels, and this is what I'm going to tell you a little bit about. Presentation is small. It's taking about 20 minutes, so I think it's not enough time to talk about all the issues related to safety. What I'm particularly interested right now is to provide you with some introduction to issues related safety of small vessels. Small vessels are vast part of international and domestic shipping. People familiar with ship construction know that around the world we have around 1,000 seagoing ships, but the number of smaller ships, which are not SOLAS classed. So it's well, hundreds of thousands small ships. So recent research showed also that pollution from small ships is quite big. I do not know the figure, but it's a quite important issue for harbors, for authorities, for communities which are sitting around the shore. So my presentation will touch a little bit to rules regulation issue, which is very important to set the design of a ship to be operated, to be certified with safety in mind, because no one is interested to have problems, and the failures and the disasters are not doing well for anyone. And social reception is, of course, very negative. And some comments on propulsion, on some case studies we are familiar around about the alternative fuels. We start with something which is to imagine you a little bit, what does it mean small ship? Small ship or craft, we normally understand it's something small with regulatory matters, it's with land below 24 meters. Of course, this is something which could be discussed, but to define if the ship is small, we have to take into account length, draught, beam. We can consider size, we can consider propulsion and some additional issues. Of course, number of crew passengers could also be kind of sign distinguishing between if ship is smaller, bigger, or anything like that. So from safety point of view, on a small ship, what we have critical, it's first of all, it's basically lack of space. We can have problems with weight and buoyancy. We can have problems with satisfactory solution to protection in fire matters. We can have problems with the structure. And right now, because a very popular issue is construction of small ships from reinforced plastics, this is another issue very important for safety in case of alternative fuels are going to be used. So one very important remark, it's quite common that majority of small ships or craft designs are prototypes. So this is something which is to be taken into account, because the matters of safety must be very detailed considering. Must be attention given to safety issues is very important, and it has influence on final certification and possibly the additional requirements which are going to assure safety of the ship in operation. Definition of alternative fuels, it's something which was defined by European directive, and basically means that alternative fuels means fuels or power sources which serve at least partly as a substitute for fossil oil sources in the energy supply to transport means, and which have the potential to contribute to its decarbonization and enhance environmental performance in the transport sector. What does it mean? It means that alternative fuel is electricity, is hydrogen, biofuels are considered as alternative fuels, synthetic fuels. One of the synthetic fuels is maybe very not well known, is dimethyl ether. We have a case study on this later. Of course, we have natural gas, compressed natural gas or liquefied gas, and we have LPG. In the green color, I tried to distinguish the fuels which have some maturity potential, which allow easier application on smaller craft. Some examples, I think for many people interested in ships are very well known. This is Pusher, which is a project in Germany, quite advanced with use of hydrogen. This is Alster Sea, small passenger craft with fuel cells, which was constructed over 10 years ago. And small craft for Netherlands, Rotterdam, as far as I remember. So this is basically what the small ship is looking like. Some guidance, what we have to take into consideration. First of all, if we have to have fuel on board, we have to consider what is the way to convert this into energy which is used on board. So storage of the fuel is the one issue, conversion means the other issue, and conversion into propulsion or into hotel purposes is also another issue. So for designer, as Mr. Czerski showed, not only the electric diagram is important, but also all other systems related to conversion of the fuel into usable waste, into usable energy, which is consumed on board. Regarding the regulations, rules, because everything which is being designed and is to be constructed later needs some survey of the construction and finally certification or classification, because to have ship to be operated, we have to have documents. So regulations are very important, and basically we have two sets of regulations. One set concerns IMO, which is governing body for international shipping, and such major document for this is IGF code, which allowed to use fuels with flash point below 60 degrees to be used as propulsion means for seagoing ships. This document is very important because it provides basic safety solutions for the use of LNG. And right now, quite a long time work is going on the extension of the IGF code to include hydrogen. I don't know when it will be. We are involved in some works on this because of, as a member of IAX, we are working on assessment of some IMO documents. We are issuing our own guidance, but IMO IGF code is a primary document which was later incorporated into classifications rules of any society. On the inland waterway side, we have European regulation. It's a directive on technical means for technical safety means for inland waterway ships. For right now, this document, which is quite fresh, 2 years old, I think, it's concerning on the use of LNG. No regulations are included for the use of hydrogen or other type of alternative fuels. I know that the work is ongoing, so maybe this will be completed in a coming year or next year. Concerning the alternative fuels, we have to consider hazards, we have to consider risk, and we have to elaborate mitigation measures. For I got the hydrogen case as quite interesting right now because it's a lot of information in the media, not very much on the technical side, but some problems which may arouse are related to the fact that hydrogen can ignite, and sensing the ignition of hydrogen is not so easy. So a lot of effort to prevent any problems is to be done on elaboration of protection measures, elaboration of passive fire protection, and of course installation for detection monitoring of hydrogen-related compartment on board ships. Problems which could arouse from use of compressed hydrogen are quite similar as with the liquid hydrogen, but one advantage for compressed hydrogen is that we can store it for a longer time in a storage bank or pressure vessels, while in the case of liquid hydrogen, if this is taken on board, it must be used. So any installation for optimization of the use of liquefied hydrogen on a small vessel is not having chance to be implemented. Regarding some guidance on ship on construction for in case of the use of alternative fuels, I already mentioned that in case of small ships we have quite a lot of limitation. We have limited space on board. We have very limited size of machinery compartment. If someone would like to build a twin hull, place space in each of the hulls is very limited. So quite a lot of equipment is to be taken on the deck. Depth limitation could be a problem, particularly in case of inland waterway ships, and of course, case of LNG. Because IGF code imposes a lot of safety requirements for piping installation, for separation of the compartment. I'm not very convinced that every requirement from LNG, from IGF code could be implemented on a small ship. So it's a big role of designer, of certification authorities, classification society, if class is providing supervisory on the ship design and construction. As some summary of the safety principles, you can see something I put on this slide. Technical progress is, of course, much more effective if we have number of applications. If applications are single, one country, one application, another country, two applications, maybe completed projects, this is something which is very difficult to consider when we would like to use probability as a measure of assuring safety. So in the case of prototype ships, maybe the use of data from data and experience from automotive sector will be useful. And this is something which could be taken into account when new ship designs will be considered. However, automotive is using different materials. On board ships, we have quite different situation regarding environmental issues. We have humidity, we have rolling, we have quite a lot of another issues which are related to the fact that not everything is safe on board ships. So, as I mentioned, in case of vessels built from plastics, from glass-reinforced plastics, this could be a problem if you would like to place something which is risky from current experience. When we want to place it into a closed compartment, then we must assure right placement, right passive fire protection, right active means for firefighting, and sometimes maybe the solution will be to place all the machinery into something which is brought in solars as equivalency to steel. Plastic is not equivalent to steel. Steel has a limiting temperature point 925 degrees. In case of plastic, nothing will stand longer than if temperature will reach over 150 degrees. Potential problem also for design and certification is right design process, right as evaluation of energy demand, and of course potential problems. We know that on board ships we have main power, we have auxiliary power. So in case of any application of alternative fuels, this must be taken into consideration as well. Right now, I would like to provide you some information about the interesting projects with alternative fuels. One is, as I mentioned, DME, and another is methanol alternative. What you see in this picture, this red boat is something which was built in Sweden. It's a pilot boat, which is using methanol as a fuel. On the lower slide, you see a yacht. This yacht is constructed. The yacht is Polish one. It's a floating laboratory of Gdańsk Technical University. And the interesting point is that it was converted to use DME as a fuel. So in this case, project was completed by mechanical department of Gdańsk Technical University. Full set of risk analysis was done. Typical yacht engine was converted to use DME. A lot of additional measures to have continuous monitoring of condition of the fuel system and all security systems. And on the right side, you see how the problem of storage of DME was solved. DME properties are very similar to LPG. So because this is a kind of experimental craft, two LPG tanks are fitted in the rear part of the yacht. And we did certification of this boat, and its primary use is for research. But it shows that there is potential in Poland, in particular in Gdańsk, to consider something which is experimental and could have a positive effect on possible practical applications. As mentioned earlier, this Swedish pilot boat is using methanol, and it shows how the solution for storage of methanol was shown. This is bunkering. On the lower slide, you see bunkering station. On the upper slide, you see tanks. Tanks are, of course, made of stainless steel. Everything is done to have ability to use it in a safe way. As you know, methanol is fuel with flash point below 60 degrees. So a lot of concern was put on safety in this case. We were talking about, or you were provided with some information about the liquefied hydrogen, about the compressed hydrogen. Of course, designer will decide which type of fuel will be better for the certain project. What I would like to show on this slide is how we are able to store compressed hydrogen on board, because such project for pressure vessels to be potentially used for compressed hydrogen was conducted in Poland. There were some composite pressure vessels designed and were type approved for another application. But it's quite popular that type 3 pressure vessel is used to store, to transport hydrogen, because it's a lot of advantage due to weight of the cylinder. Of course, you can use a metal cylinder, type 1. You can use type 4 cylinder, which is something of quite similar design as type 3, but the liner inside is made of plastic. In the cylinder type 3, the metal liner is made of metal. So it's much better in case of potential protection about hydrogen embrittlement and permeation, which could be a problem. A safe place for hydrogen in this case, but some guidance could be taken in case of other low flash point fuels. As earlier was talked, placement of hydrogen cylinders on a pusher. This is the best place because we have shallow draught, machinery is put forward, azimuth drives probably are placed over there. So this allows to put hydrogen banks, hydrogen containers on board. Refueling could be done quite easily by exchange of cylinders. In case of another vessel, which is TAG, which is under construction in one of the Benelux countries, hydrogen storage is placed under the deck over there in the rear part of the vessel. In case of this vessel, which was one of the first vessels successfully completed and operated with fuel cells in Hamburg for a couple of years, hydrogen cylinders were stored in the bottom part of the vessel. What is interesting with that vessel is that suffered fire some years ago. Fire was quite disastrous and all the infrastructure was destroyed, but nothing happened to the cylinders. So it's one of the cases I'm familiar that fuel cells and hydrogen could be quite resistant to potential problems. As conclusions, what I would like to point out that in case of alternative fuels, we have a different situation. We have to put more attention on design. Design could be more complex. It's not the same situation as we have with in case we have with traditional fuels. Diesel engines are used on board ships over 100 years. And right now, the statistics is that every year, if someone will consider accidents on board ships, about 30% are fires. What it will be with alternative fuels, I do not know, of course. But identification of potential problems is a prime task for the designer. Identification of problems with insufficient propulsion on early stage of design is another issue, because if we consider electrical power as a alternative fuel, someone who is future owner of the ship is interested in having the lowest price. So it could be stressed. A designer could be under stress to select lower power. But we did a study on this issue, and especially in some the smaller inland crafts, it happened quite often that propulsion power was too small to cope with environmental issues, because in case of battery, we have limited capacity. In case of construction, the underwater part is small, upper part is bigger. So if the power installed for propulsion is too small, ship could not be able to fight with the wind and with the waves. So it could influence on final certification of the vessel, because allowed operational area could be drastically shortened. Well, I think that the very important is the ability to discuss with regulatory bodies the issues. Right now, maturity of technology concerning hydrogen is not same as with diesel engines, where it's a lot of gaps, it's a lot of information which is kept by designers of the vessels, because designers by the ship equipment. So to get finally the safe design, I mean, the open discussion with certification body, with classification society is necessary. And I recommend this is to be done as early stage as possible, because we know quite a lot. And this knowledge could be for benefit of future design. It's, I think, the final conclusion. In case you have questions, in case you have some problems, when possibly we can support you, I recommend to turn to Polish Register of Shipping. My contact data are in the end of this presentation.
Thank you, Mr.
In case of
Narecki.
questions, you are welcome.
Thank you for the great and in detailed presentation about Postgres of Statków, our partner. It was really great to see the point of view from the shipping side, what are requests, what it needed to how they can be met by the small vessels. Excellent. As we are a bit in front now and we are short on time, I would like to invite our next speaker, Mr. Margus Wichmann from Ports of Tallinn, to give us a presentation on the implementation of LNG and onshore power supply infrastructure in a port. Port of Tallinn has been leader for a while in the region, and we've been cooperating in few projects introducing LNG infrastructure. Now we have a couple of ships running there on LNG on daily basis. There's LNG bunkering ongoing there. You wasn't one of the examples there in the region, and I'm sure you're serving as a know-how from most of the ports in Europe. So I'm really curious to see what is the latest from Port of Tallinn. So Mr. Vipan, if you can give us your presentation.
Very much for the introduction. Please tell me if you can see my presentation.
Yeah, we can see it. Please go ahead.
All right. So I'm Margus Vihman, Chief Commercial Officer, member of the Management Board of Port of Tallinn. And I'm telling you a little bit about the things that we do with the green ambitions. Okay, so just to understand who we are actually a listed company, which is quite rare in the area. Usually the companies, port companies, are owned by the local government or government. We are a publicly listed company in Baltic Nasdaq, which is part of the American Nasdaq, but 67% of our shares is owned by Republic of Estonia, and 33% are on a free flow, so these can be bought from the stock exchange and hopefully made some profit on that. Don't let the name fool you. We are actually not only working in Tallinn, capital of Estonia, but we are the biggest port authority in Estonia. We operate currently 4 ports. We have 4 business areas. Actually, we are the 3rd biggest passenger port in Europe after Helsinki and Hull. And then we are competing with Stockholm for the 3rd place. Then we do the cargo, and we service over 10 million passengers annually. So on a good year, of course, with the COVID crisis, the number has decreased a lot. Now, in cargo, we make annually about 21.5 million tons. We are also ship owners. We have icebreaker, and then we have actually 5 ferries that we use inside of Estonia, and we service mainland and 2 biggest islands in Estonia. And then 4th biggest business field is real estate, which we have the industrial parks, of course, in the port area, but we also have 16 hectares of prime land in the old city port, right near to the city center. If we talk about the passengers, the main passengers, of course, go between Tallinn and Helsinki, and we service in a normal year about 8 million persons there. Then we have lines to Stockholm and cruise lines to St. Petersburg, and we also service about 650,000 cruise passengers annually. Now, one thing that we are proud of and what we have been working for many years now is sustainable development, and this is a frame that our strategy is built in. As you know, in 2015, the United Nations Summit Declaration Transforming Our World, the 2030 Agenda for Sustainable Development, was approved, and to achieve these goals, also we are doing our part, and we have chosen. You can see these emoticons in the middle from this UN summit. Some of the points that we can react to and have our impact. And today I'm talking more about the environmental impact. As you know, the climate neutrality is the goal for 2050, and we want to decrease the CO2 by 50% already by 2030. So how do you do this? The first thing, you probably have to know where are you, because if you don't know where you are, you don't know what goal to put for yourself. So what we did is mapping the CO2, and we had 3 scopes there. So port direct, which means the fleet that the port own, vehicles, buildings, stationary sources, how much is the CO2 emission there? Then scope 2, indirect, which means the purchase the electricity for port-owned buildings and operations. And the most difficult one, scope 3, which means the port tenants and other resources. This means ships, trucks, cargo handling. So basically, we don't only cover our own emissions, but everybody who is interacted with the port, even a Ro-Ro passenger car that is going into the Ro-Ro vessel is calculated into this. And what we found is that totally we emit 97,426 tons CO2 annually. We also understood where it's coming from, and as you can see, the biggest emission is still from the vessels, 53%, and the second biggest is 23% from the electricity. All the others are smaller, and with electricity, it's very easy to solve. We actually have done it already. We are using now only green energy in our ports, so this is already reduced. With the vessels, it's totally different story, and it's more than a half. The first step that we are taking now, and it's already in the action, is onshore power supply. And as you know, the difficulty in this is that there is very many different standards, but we have managed to agree with 4 ports to set a common approach for the new offshore power supply. And the standard is 11 kilovolts, and the frequency is 50 hertz. And this is mainly for the Ro-Pax vessels going between Helsinki and Tallinn. And we also agreed with Helsinki, Turku, Stockholm, and Tallinn, of course, that we will jointly encourage other ports and shipping companies to follow this initiative and use the same frequency and voltage. And of course, we have talked this through with our biggest clients. All of these ports have the biggest clients of these ports are the same. So Tallink Silja Line, Eckerö Line, and Viking Line. Also, a good thing is that we managed to get the EU funding for this, and we have a project called Twin Port, and I think we currently already go with the 5th round to get the EU funding, but this was financed with a 3rd round. And the EU funding rate for this onshore power supply was 30%. We invested 3.5 million. And for example, Tallink today has 5 ships that are able to connect to the onshore power, and they have invested 3 million euros. But in the future, we would like to have 12 ships, and Tallink will invest up to 6 million euros into that. And where we currently have is we have 5 keys supplied with the ops systems. 3, 5, and 7 is for the Tallink, 12 is for the Viking Line. 12 is for the Eckerö Line, and 13 is then for the Viking Line. And basically, what you need for the ops connection, very important, is main incoming substation, because if you don't have the amount of power available, then you have to somehow build this. Then power cables, shoreside substation, then the berth terminal, and of course the ship has proper equipment to receive this power. And our partner in this was ABB, also ShoreLink, main partners, and they managed to build 6 cable dispenser units, 5 shore substations, and like I said, 11 kilovolts and 50 hertz connections. And here we go again with the 5 keys. And the project duration was 1 year. And we also calculated the environmental benefits. So 1,440 tons of CO2, 20 tons of nitrogen oxide, and 820 kilos of SOx, So basically this is all minus. So this is what we have benefited from that. Now coming to the alternative fuels, still the most popular alternative fuel at the moment is LNG. And we have had this fuel in our port since 2017. And the company Elenger, which is part of the Estonian gas company, has been providing this for us. And they have also done all the preparations and permits. They have done also the hazard identification and hazard and operability study. So all the risk analysis has been done. They supply, they do the logistics, they also do the customs because the LNG is mainly coming from Russia. And they also do the operations and technical management. We currently have one ship that is using it constantly in Old Town Port, and this is Tallinn ship Megastar. And they are bunkering from the trucks to the ship. One truck is about 250 cubic meters. 25,600 cubic meters, and they are doing 4 to 6 trucks every night. So quite time consuming. What they want to do in the future, and most probably will be launched this year, is LNG bunkering ship, and this has capacity of 6,000 cubic meters. Also, we already have all the risk analysis done, and potential user, of course, will be Megastar. They will have a similar sister ship next year, which will be called MyStar. And also, they are planning to supply cruise ships and cargo ships in the Baltic Sea. Now, just to understand the 6,000 cubic meters, how much it is that Megastar has 2 300 cubic meter tanks. So 6,000 is quite a lot. I would call it already medium size bunkering vessel or a big size bunkering vessel, but maybe comparable to a terminal already. And the main operation area will be Gulf of Finland. Vessel can act as feeder or bunker vessel in the eastern part of Baltic Sea. This is meaning that they will still have trucks. So sometimes what will happen is that they bunker from the ship to the trucks, and the trucks actually do the bunkering to the ship, or why not some vessels or factories that are on the shore. They are can provide bunkering to different type and size of vessels. Mainly, there will be tankers, cargo ships, cruise ships, passenger vessels. Vessel is capable to do the bunkering in anchorage point, so not inside the port, but also inside the port. And we also know that the vessel is highly maneuverable. So can operate in very different type of ports. Now, another project that we have is one of the ferries that we have going between the islands and the mainland. And we have created it as a hybrid ferry, which basically acts as the hybrid car. So uses has battery packs which he can use in the time that there is high voltage or high power needed, and this means that we can use about 20% less diesel fuel, and of course we then lower the emissions also, and we have calculated that annually 1,600 tons of CO2 can be reduced. Also, the Voyager is much quieter. We don't have the underwater noise and vibration and pollution. So better, cleaner living for everyone. And the The previous speaker had a very good presentation about the hydrogen. We are also thinking about that, and one of the main reasons still is that LNG definitely is a temporary solution. As you get minus 99% of the sulfur oxides and 80% of the nitrogen oxides, this is very good fuel. But if you look at the CO2, then the reduce is only 25%. And we need in the future some kind of a new energy, and hydrogen is what we are betting on. So also we have to think that 40 to 50% of our turnover in the port system is oil and gas, and this definitely will be reduced. So if we want to keep up the cargo amounts in our ports, we have to also look into the new energies. The prices of solar and wind energy are decreasing, and Baltic Sea will definitely be one of the good places to have offshore wind parks. This is also something that is for the favor of the hydrogen, because you can save the energy into the hydrogen and then release it where you need it. And then we really see a good opportunity here, and would like to set up a hydrogen value chain in Estonia. And we see us as a kickstarting of the value chain here, to do the infrastructural hydrogen backbone, which means probably in the beginning smaller terminals, or even bunkering stations, and then building them bigger and bigger. We would like to become at least the Baltic hydrogen hub, meaning the three Baltic states. We would like to operate hydrogen vessels, and also thinking about the internal logistics in the port to be re-engineered into the hydrogen. And of course, the collaboration with the port, within the port area. So everybody who is using our land or has the terminals in there, we would like to also get them to use the hydrogen. But not only, I also think that in the longer run, we could be the ones that supply the hydrogen tanking points, or even work together with the public transport or something like that. One of the first projects that we are thinking about is that we have the OPS for the line carriers at the moment, but we don't still have them for the cruise ships. And the problem with the cruise ships is that they're very, very big, more than 300 meters long, and the consumption that they can have is compared to a small city in Estonia. So for us, it could be difficult to get the needed amount of power into the old city port for these cruise ships. And one of the things that we have been thinking of is combining the grid power with the hydrogen, which means that we could actually record 16 hours in a day in the electricity into the hydrogen, and then for the 8 hours that the cruise ships are in, supply the cruise ships partly with the electricity power that we get from the hydrogen. Also, we are planning to probably have the 6th ferry in Estonia between the islands, and this will be operated purely on batteries charged from the electric grid. But we are also thinking that it should have the readiness for the hydrogen, and also the possible retrofitting of the existing ferries. The LMG is the mark of the ferry, which is then the type model of the LMG Marine, the Norwegian company that has been designing these companies. And these ferries. We totally estimate the reduction of CO2 with this by 55%. And also we are thinking about in Paldiski or Muuga harbor of having the medium or small size, but in the future, why not the big size terminals for the hydrogen. So if anybody is interested in that, then please contact with us. And we also have the cooperation with the Hamburg Port Authority and Roenne Port Authority to have this connection line that would have the possibilities of having bunkering facilities in these ports. And finally, what we see is first step is internal logistics, trucks, heavy lifting equipment built on hydrogen by 2023. Then secondly, public transport and ferries, providing hydrogen for freight and public transport, buses and trains by 2023, 2024, providing hydrogen for domestic ferry industry, also providing hydrogen for internal ferry industry. And the third stage, somewhere around 2030, will be then providing hydrogen for shipping and export. So that's it. If you have any questions, then I will be glad to answer.
Thank you, Mr. Wimman, for the excellent picturesque presentation of Port of Tallinn, and we are glad to see you continuing on the same path with introducing LNG, bio-LNG as well to come, and OPS, and as well aiming for the future fuels and concentrating on the hydrogen and other solutions. Thank you for your support and joining us today. If there are any questions, they will be forwarded to you on the.
Thank you very much. Thank you for having us. Bye-bye.
Thank you. And I would like to continue further with our last presentation, but not the least one, from Mr. Piotr Kabaczynski from Varsila, Finland, to give us a presentation on the future fuels outlook. And Piotr, I hope you've got your crystal ball today to give us a prediction of the future, and what is the fuel of the future?
Good morning. Ships are transporting 90% of all cargo in the world. During that operation, they are generating 3% of all greenhouse gas emissions. Therefore, IMO introduced a set of targets reducing carbon emissions comparing to 2008 level. At least 40% reduction by 2030 and 70% reduction by 2050. This chain of bubbles on the left represents the possible actions that the ship owner can take to reduce the emissions. The higher we go, the more expensive it gets. Starting from the bottom, optimized voyage means, for example, lower vessel speed or optimum vessel routing. Second bubble considers the energy need. This means all kinds of optimizations just to save as much fuel as possible. Next bubble is about power distribution, which includes battery hybrid systems to increase the efficiency. These three first steps, everything that is under the yellow line, will be enough to comply with the IMO 2030 target. Then, in order to reach the 2050 limit, the last bubble is top important. It is about energy generation, which basically means switching to green fuels. Here we have all fuels listed. They are categorized into three groups: fossil, bio, and green. Fossil fuels will be disappearing sooner or later due to the environmental restrictions. Biofuels can be serving as a separate topic, and this presentation is about green fuels. When I was making the research on this material, I found that naming is quite confusing. Names and abbreviations listed here, they all mean the same. To make it simple, power fuels are produced from renewable energy. This diagram shows several possible pathways to different power fuels. It is clear that the key building block here is the green hydrogen, not as a fuel yet, but as a building block. And before any green hydrogen is produced, the very starting point is the renewable electricity. And in fact, we need a lot of it. Scaling up is the only way to minimize the cost, because today renewable electricity is about 3 to 5 times more expensive. If we already can produce green electricity, then we shall send it straight to the existing grid. It is a no-brainer. This is the most efficient way because no energy conversion means the least possible losses. Sometimes, however, it is not possible to get connected to the grid. Either it's too far away or there is a too big supply of the green energy comparing to the existing capacity. Here is one example. Glomfjord is the most windy area in Norway, and there is no capable grid existing there. In such case, the power fuels will be necessary. Pretty much the same is with shipping. Green electricity can be used for short distance ferries or inland waterways, but ocean-going vessels will be definitely needing power fuels. As it was mentioned already, hydrogen plays the essential role as an energy carrier. But this hydrogen must be produced from renewables. Today, however, hydrogen is extracted from fossil fuels in the pollution-heavy process. Green hydrogen does not exist today. This is how the green hydrogen is produced. Water electrolysis is known for many years. It is how the oxygen is produced on submarines. When electricity starts to flow between the electrodes, hydrogen is formed on the cathode, oxygen on the anode. This animation shows the alkaline water electrolysis process, but there are also some other methods shown on the right. Here I compiled some of the main challenges related to hydrogen together with the hopes. And let's focus on these hopes. Hydrogen is used as an energy carrier. It serves as a building block for synthetic fuels. And many countries already have the hydrogen strategy in place. Let's take the European Union, for example. Total electrolyzer capacity in 2019 was 250 megawatt. In 4 years, it is expected to grow by 12 times up to 3 giga, reaching 1000 giga by 2050. Let's talk about the power fuels now, and allow me to introduce the 4 candidates to the Fuel of the Future award. We discussed about the hydrogen already, but this time we will consider it as fuel. Hydrogen has very high energy density. 1 kilogram of hydrogen has almost 3 times bigger energy content than the gasoline. The problem is that this 1 kilogram of hydrogen takes 11 cubic meters of volume. Therefore, we must either compress the hydrogen at 700 bars or liquefy it at minus 253. And quite frankly, today it is hard to imagine such conditions on board any vessel. Now, how to use that hydrogen for electricity production? This can be done inside the fuel cell unit. It is a reverted process to electrolysis. There are already few suppliers offering the fuel cells even to the marine market, but I will say no more about this technology. Why? Because I am Wärtsilä and my heart is beating in accordance to the 4-stroke cycle. Wärtsilä dual fuel technology is already capable of burning hydrogen as fuel. We mix up to 25% of hydrogen with natural gas, and we do have the ambition to create the pure hydrogen engine. Moreover, we already know how to handle the cryogenic LNG at minus 160. Therefore, it will be easy for us to adapt to liquid hydrogen when the time comes. The next candidate is ammonia, green ammonia. During my research, I found an important quote that ammonia was a detonator of population explosion. For over 100 years, ammonia has been the main feedstock to make fertilizers. Thanks to ammonia, we are capable of growing more crops, feeding more people. Ammonia is easier to store than hydrogen. We need only minus 33 degrees to make ammonia as liquid. But green ammonia does not exist today, same as there is no green hydrogen to make it from. To produce ammonia, we need nitrogen, and nitrogen is not a reactive compound. So in the Haber-Bosch process, we are forcing it to react with hydrogen. This requires high temperature, high pressure, and a catalyst. And apparently, there is no better way yet than Haber-Bosch process. And here again, the solution is the Wärtsilä dual fuel technology. We can either blend ammonia with natural gas before the engine, or we can mix ammonia with diesel inside the combustion chamber in a specific ratio. When needed, we can easily convert our standard LNG pack system to something like ammonia pack. Next off is green methanol. As you can see from the chemical notation, green methanol is not a zero carbon fuel. Methanol today is made from fossil fuels. It's mostly used for production of chemicals and plastic. Methanol is easier to store than ammonia because it is a liquid at ambient conditions. As for renewable methanol, there are two types: biomethanol from biomass and e-methanol from green hydrogen and CO2. To produce green methanol, we need carbon dioxide, CO2, which has to be captured first before it's added to hydrogen during the synthesis process. Since 2015, we already have the valid reference of methanol as fuel on Stiena Germanica vessel, which was converted at Remontowa ship repair in Gdańsk. This technology can be transferred to all our portfolio engines. The last candidate on my list is the synthetic methane, which is basically the same molecule as methane. For the ship owners, it means business as usual. Something to keep in mind is that burning the synthetic methane in the engine is still related to CO2 emissions, but the way the fuel is produced is carbon-free. On dual fuel technology our dual fuel technology is already proven in burning natural gas. Using synthetic methane is the best gateway to carbon-free fuels, because today you just operate on natural gas. Tomorrow you will convert the system to carbon-free gas. Now we can start summarizing. In principle, there are two possible strategies. The first is you do nothing and just wait for synthetic fuels to come. Second strategy is for those who want to become carbon-free as soon as possible. In principle, it means switching to fuel which doesn't include carbon, like hydrogen and ammonia. At first, you can start blending carbon-free gas to natural gas. Then, when the technology is mature enough, you switch to pure ammonia or pure hydrogen. The word omnivore means that internal combustion engine basically can eat everything. In the transition to green fuels, the engine is not the limiting factor. Engine as such will stay almost the same. The only changes inside are about cylinder heads and piston crowns due to the different compression ratios. So if the engine is not a limiting factor, then what is the problem? One important aspect to consider is the bunkering of the new fuels. Comparing to the energy content by mass, which is shown here, hydrogen looks really impressive. But considering the volume that is required on board, it looks somehow different. And maybe these bubbles will show it better. Each bubble represents the same portion of energy. So for the same energy content, we need 4.5 times more space for liquid hydrogen than diesel, or 2.6 times more space for liquid hydrogen than LNG. And these ratios consider just the volume of the liquid. They do not consider any special tank design, insulation, pumping, cryogenic. The final word. Here is our recommendation about becoming future-proof. Go gas now, go gas today. According to the research recently published by Sfera, using LNG as fuel is reducing CO2 emissions by 23% overall. And as it was mentioned already, by installing the dual fuel engines today, you are already making the first step towards carbon-free gases. So you will be able to use them whenever they come. Thank you for the attention.
Piotr, thank you for your presentation. It was an excellent summary of our webinar today. I mean, you had it all. You touched all the probable fuels, the next fuels, and of course, underlined the utilization of LNG, bio-LNG as well. It's still to be seen for a while. If there are any questions, we will forward them to you. For now, we've got just congratulations on the actual event and on the presentation. So thank you, excellent presentation once again, and we appreciate the support of Vasile and your time. With that said, I would like to follow up with a short summary of our event. We now finish the second session of the alternative fuels, the future fuels which are implemented and which are to come in the close future and in the long term. So from my side, I would like to mention that we have started with some introduction of the existing fuels, the fuels which are now running, and the LNG and bio-LNG is still holding up a strong position to be the current transition fuel and to remain for the next few decades as one of the top choices from the ship owners and ports. Hydrogen has been underlined as an important part of the European Green Deal, and is one of the leading future fuel solutions, and is explored both as direct liquid fuel and potentially as a fuel cell solutions. Onshore power supply has been represented as an important solution to limit the propulsion and emissions caused by the ships at berth, and it will be developing hopefully more after the current drawback what we have due to the pandemic ongoing in the regions in Europe and beyond. Other alternative fuels as well are holding a position to be leaders. We've seen the positive sides of ammonia as currently explored by maritime and transport sector. Ammonia is underlined as one of the fuels of the future due to the advantage that holds as a shipped commodity, and it's much cheaper to be produced and more easily stored than hydrogen. So very interesting mix. From my experience, I do not see that it will be one fuel that fits them all, and this will be followed by all stakeholders around the world. We will have a mixed bag of fuels and solutions for the decades to come. The positive side in Europe is that all these future fuels are highly prioritized by the EU Commissions and all associated co-financing programs related to the deployment of sustainable infrastructure for ships and transport and regional industry. Dear guests, dear colleagues, I would like to thank you for your attention and for joining us today for Innovation Days 2021, and our main topic on alternative fuels and what is the path for these green fuels, what is the path for the future. So thank you for our partners, thank you for our main partner, Port of Gdynia, partner Shorelink, as well Polski Rejestr Statków. Thank you for fellow speakers, and we hope you enjoyed our webinar today and hope to see you in the future. Thank you and goodbye.
Budowa portu zewnętrznego praktycznie podwoi obecną powierzchnię zajmowaną przez terminale operacyjne w porcie Gdynia.
W przypadku takiej inwestycji kluczowa jest współpraca pomiędzy Zarządem Morskiego Portu, którego rolą jest stworzenie właściwych warunków, czy to w zakresie właściwego dostępu drogowego i kolejowego do portu. Z drugiej strony partner prywatny jest konieczny do zapewnienia sukcesu dla tego projektu. Tym partnerem prywatnym musi być światowej klasy operator, który będzie w stanie przyciągnąć do Gdyni ładunki.
Z tym projektem odniesie wiele innych korzyści dla innych przedsiębiorców, dla regionu i dla całego kraju.
Port zewnętrzny będzie miał fundamentalne znaczenie dla regionu i dla wszystkiego, co dzieje się w całym obrębie Bałtyku. Bez takiej inwestycji będzie bardzo trudno konkurować z Göteborgiem, będzie bardzo trudno konkurować z Kłajpedą. Musimy być coraz bardziej nowocześni, musimy umożliwiać dostęp najnowszym, największym statkom, jakie pływają po oceanach.
To jest przedsięwzięcie, które tak naprawdę otwiera nową historię w działalności portu w Gdyni. Teraz porty morskie są wielofunkcyjnym organizmem, który oprócz funkcji transportowych łączy w sobie funkcje przemysłowe, handlowe, logistyczne. Jest też stymulatorem rozwoju gospodarki całego kraju.
Jest to olbrzymia dźwignia dla przemysłu i też kolejna szansa rozwoju dla Gdyni.
Gdynia, jak wiadomo, jest portem o strategicznym znaczeniu dla gospodarki. Dzięki bardzo takiej silnej współpracy z Ministerstwem Funduszy i Polityki Regionalnej i oczywiście innymi ministerstwami udało się pozyskać finansowanie na infrastrukturę dostępową od strony morza.
Polityka proekologiczna, którą realizuje Port Gdynia, również jest naprawdę godna podziwu. Polityka w ramach idei Green Portu, najnowocześniejszy na świecie i jednocześnie najbezpieczniejszy na świecie system nawigacji statków, który notabene jest również bardzo proekologiczny. To wszystko składa się na jedną całość i uzasadniało przyznanie nagrody dla Portu Gdynia i dla jej sternika.
Przyjęcie pierwszego statku to jest mniej więcej 2028 rok.
Poprzez zbudowanie portu zewnętrznego Gdynia wróci do tej idei, do tej koncepcji, która przyświecała inżynierowi Wędzie i ministrowi Kwiatkowskiemu, że każdy statek, który wpłynie na Bałtyk, wpłynie również do portu Gdyni.